Hello everyone, this is Chinnaiah Kalpana here. In this video, we're going to see a problem from partial differential equation. So let's get going. Problem: form partial differential equation from phi of z square minus xy comma x by z equal to 0 by eliminating the arbitrary function phi. So we are given a relation phi of z square minus xy x by z equal to 0, and we are asked to form a partial differential equation by eliminating this phi. So we can use any of these methods. Okay. I'm going to try this in this video, and in the next video I'm going to try this. Okay, let's see. Given phi of z square minus xy comma x by z equal to 0, consider some equation number 1. Now we can write the same equation as, say we are given some function of phi of something into equal to 0, then we can write this as z square minus xy equal to f of x by z, or x by z equal to f of z square minus xy. Okay, so here we will rewrite one as z square minus xy equal to f of x by z, where f is the arbitrary function here. Okay, we wrote the given equation in this form. Got it? Fine. Now we'll partially differentiate it with respect to x and also with respect to y. Partially differentiating to with respect to x, just apply dou by dou x on both sides of the equation, or if you are really familiar with differentiation, you just can do directly. Okay, most of the people don't know how to differentiate things partially, so I'm giving number of steps here. Fine. Now partial derivative of first term minus partial derivative of second term. Here we are partially differentiating with respect to x, so we'll treat y as constant, and partial derivative of f of x by z is f dash of x by z into inner derivative, that is dou by dou x of x by z. Okay, the partial derivative of z square is 2z into dou z by dou x minus, here y is treated as constant. Since we are partially differentiating with respect to x, so we'll treat y as constant. So we will write this as y into partial derivative of x with respect to x equal to f dash of x by z into, here we can apply u by v whole dash formula. We all know this, right? U dash v minus v dash u by v square. See, if you see it's too lengthy, please skip the steps. Okay, please skip the video and see what you wish to see or what you wish to learn. Okay, fine. Now this gives us partial derivative of u into v minus partial derivative of v into u by v square. Since we have a notation dou z by dou x equal to, it's dou x, okay, equal to p, we can just replace dou z by dou x by p here. We'll get dou z by dou x minus, 2zp minus y into partial derivative of x with respect to x is 1 equal to f dash of x by z into partial derivative of x with respect to x is 1 into z minus partial derivative of z with respect to x is dou z by dou x, right? Again we can replace it by p, since dou z by dou x equal to p into this x by z square. Okay, you can skip all these 3 steps and write this directly. Okay, or you can skip all this 4 and write the next step directly. See, I have a responsibility to show the steps, how it came, how the step came, and that is the reason why I am writing all these 4 steps. Okay, it's easy for me to do directly, but I am taking time to explain each and every step so that every student can understand it easily, right? Fine, now z into 1 is z minus here we'll replace it by p, we'll get px by z square, right? Fine. Now consider this equation as equation number 3. Okay. Again, we'll partially differentiate 2 with respect to y. Now let's partially differentiate 2 with respect to y. Just apply dou by dou y on both sides of 2. Since we are partially differentiating with respect to y, so we'll treat x as constant. Okay, this gives us dou by dou y of first term minus dou by dou y of second term equal to dou by dou y of, derivative of f of x by y is f dash of x by z, it's z, right? Derivative of f of x by z is f dash of z into, what I'm saying, f dash of x by z into partial derivative of x by z, that is inner derivative, right? Here x is constant, so we'll write this term as x into dou by dou y of 1 by z. Fine, this gives us 2z into dou z by dou y minus, here x is constant, so we'll write this as x into dou by dou y of this y equal to f dash of x by z into x into dou by dou y of 1 by z. Since x is constant, so we wrote it beside partial derivative, right? And we know that dou z by dou y equal to q, which is a notation, and now we'll replace dou z by dou y by q, so that you'll get 2zq minus x into partial derivative of y with respect to y is 1 equal to f dash of x by z into x into partial derivative of 1 by z with respect to y is minus 1 by z square into inner derivative, that is dou z by dou y. Okay, or here also you can apply u by v whole dash formula. What you'll get, see, let me show you. Partial derivative of x with respect to y is 0 into z minus partial derivative of z with respect to y is q into x by v square, that is z square, which gives us minus xq or qx by z square. Okay, this is what we are going to get now. Again, just replace dou z by dou y by q, you'll get x into 1x equal to f dash of x by z into x into minus 1 by z square into, we'll just replace it by q, then you'll get minus xq by z square. We'll get the same thing. Okay. Minus xq by z square. Now we'll consider it as equation number 4. So we got equation number 4, which is 2zq minus x equal to f dash of x by z into minus xq by z square, which is considered as equation number 4 here, right? Now observe equation 3 and 4. Can notice that f dash of x by z exists in both the equations, so using 3 by 4 we can just eliminate this f dash, right? Let's see. Fine. Now using 3 by 4 we'll get LHS of 3 by LHS of 4 equal to RHS of 3 by RHS of 4 where z square gets cancelled, f dash of x by z gets cancelled, and you'll get 2zp minus y by 2zq minus x equal to z minus px by minus xq. Now make a cross multiplication and simplify it. This gives us minus 2x z pq minus into minus plus x y q equal to z into these two terms 2z square q minus xz minus into plus minus px into 2z q is 2xzpq minus into minus plus px into x px square, right? So here minus 2xzpq gets cancelled from LHS and RHS, and you'll have xyq equal to 2z square q minus xz plus px square. Okay, now write the terms that involves, here you're having negative minus 2z, right? We can just bring this term to LHS and take this term to LHS so that you'll get all the terms that involves PQ in RHS and the terms that does not involve PQ in LHS, okay? Since we are having minus here, so that we are taking or bringing it to LHS, okay? Otherwise, we'll write all the terms that involves PQ in LHS and we'll take the terms that does not involve PQ in RHS. I'll bring this to RHS so that it becomes minus xyq, or we can write the same thing as 2z square q plus px square minus xyq equal to z xz, which is on the right track, right? Fine. Now, this is the required partial differential equation. Okay, or let's write it as x square p plus 2z square q minus xyq equal to xz or zx, whatever. This is required partial differential equation. Therefore, x square p plus 2z square q minus xyq equal to xz is the required partial differential equation. This completes the problem. See, this is another method to solve the same problem. Here I picked v equal to f of u. Okay, v equal to f of u. For v equal to x by z and u equal to z square minus xy. You can solve in this way. I just did a shortcut method. Fine. If anyone of you wants to try this second method, here is the answer. You can check it out. Okay. Now in the next video we'll see the another method of solving the same problem using determinant. Well, we have seen a problem from partial differential equations in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.